Okay, guys, this is a free response type of questions on binomial distributions here. So I have three examples, and this should go fast. So a quality engineer selects a simple random sample, SRS, of 10 switches from a large shipment for detailed inspection. Unknown to the engineer, 10% of the switches in the shipment fail to meet the specifications. What is the probability that no more than one of the switches in the sample fail inspection? Okay, this is a binomial because it either is successful or it fails. There's only two options here. So what we're going to look for, you guys, is we want to know the probability that our x is going to be less than or equal to 1 because it says no more than one of these guys right here. All right, so that could be 0 or 1. So probability that x equals 0 plus the probability that x equals 1 right here. All right, so we're going to use our binomial PDF. PDF means we can do them singly. So 10 switches, 10% of the time. So the 0.1 is 10%, and then 0 plus 10 switches, 10% of the time with 1 right there. So no more than 1. So we can punch those individually in our calculators, and we get 0.3487, 0.3874, and it adds up to about 0.7361. Okay, now let's answer this. Don't leave it like that. I'll never leave it like that. Always answer it in the context of the problem. So what is the probability that no more than one of the 10 switches in the sample fail inspection? Well, I'd say something like this. This means that about 74%, or you can say a little less than 74%, of all the samples of 10 switches will contain no more than one bad switch. Okay, so make sure you answer it in the context of the problem. Okay, so here's another one we did in class. So Kareen is a basketball player who makes 75% of her free throws over the course of a season. Okay, this one's a binomial because she either makes the free throw or she doesn't make it. So it's either in or out. So there's two choices. In a key game, Kareen shoots 12 free throws and makes only 7 of them. And so the fans think that she failed because she was nervous. Is it unusual for Kareen to perform this poorly? So to answer this question, assume that the free throws are independent with probability of 0.75 for 75% of the success on each shot. So then they say that studies of long sequences of free throws have found no evidence that they are dependent of each other. So it's a reasonable assumption to say that it's independent right there. So the number x of baskets, so which means the successes in 12 shots, has the binomial distribution. So this B means binomial distribution of 12 free throws, and each one is 75%. So binomial, 12 free throws, 75% for each one. That's it. So that's my distribution right there. Okay. Oops, I lost my little cursor there. Okay, so we want the probability of making a basket on at most 7 free throws. So at most means less than or equal to 7. So we can do the probability that x equals 0, binomial PDF of x equals 0, then binomial PDF of x equals 1, x equal 2, and then 3, 4, 5, 6, 7, and you can add all those up right there. Okay, and your calculator will give you these. Or you can do the binomial CDF. The CDF means cumulative, means it's going to add them all up. So it'll add, we could have done this on the other problem also, you guys, on the prior one. Binomial, but write this down. Tell them what you're doing on your AP test. Write down, you're writing down binomial CDF. So 12 comma 0.75 and then 7 right there, and you plug that in, and you're going to get still the same number, roughly a little under 16%. Okay, so make sure you answer it in the context of the problem. So Kareen will make at most 7 of her 12 free throws. About 16% of the time, or a little bit less than 16% of the time, or roughly 1 in every 6 games. Boy, that would sound sweet if you change that. 16% is roughly 1 out of every 6 games. So while that's below her average, the performance is well within the range of the usual chance of variation in her shooting. Okay, that would be dynamite if you can just kind of wrap it up with something like that. All right, so here's a family that they want to have 3 girls right here. So we wanted to determine the probability that all 3 children in a family are girls. Okay, and we're making the assumption that it's 50-50 on girls versus guys. And I know, if you study genetics, depending on the the family, it sometimes isn't 50-50, but we're going to make the assumption it is 50-50. So this is a binomial, whether it's a girl or not a girl, with 3 kids and 50-50 on that. So it has that distribution. We want to find the probability that the number of girls is 3, so equals 3. So this one's a PDF, equals 3. Okay, so you're going to go ahead and punch that in, and you get about, if it's 50-50, you're going to get about 12.5% of the time it's going to be all 3 girls. Okay, all right, and I'll let you finish that on that. All right, take care, you guys.